All right, homework 9.3, we're finding the inverses of exponentials and logs. Do a couple of these. Remember, to find an inverse function, we switch x and y. So all we need to do here is switch the x and the y value, and then solve for y. So we're trying to get y by itself. So we need to isolate this log. We're going to add 1 to both sides. And so we get x plus 1 equals log base 7 of y plus 5. To cancel out the log, to get rid of the log, we need to do an exponential. So 7 to the power of the whole side. 7 to the x plus 1 equals y plus 5. And lastly, we're going to subtract 5. I'm going to go ahead and switch sides so that the y is on the left side. Y equals 7 to the x plus 1 minus 5. That's the inverse function. I guess I'll do one exponential. Let's see, C, we need to switch x and y. So it becomes x equals 2 times 4 to the y minus 2. We need to isolate the exponential, so we're going to divide by 2. X divided by 2 equals 4 to the y minus 2. Once we have the exponential by itself, we can take the log base 4 on both sides. And so we get log base 4 of x over 2 equals y minus 2. I'm going to add 2 to both sides and get y equals log base 4 of x over 2 plus 2. Now, something I'm going to do here. I noticed that log base 4, this is a dividing, and we can use properties of logs here to simplify this, and I'm going to go ahead and do that. This is log base 4 of x minus log base 4 of 2. And the reason I'm doing this is because I can evaluate log base 4 of 2. This is saying 4 to what power gets you 2? And the answer is 1/2. And so I can combine these and get y equals log base 4 of x. The way you combine a whole number and a fraction is you get a common denominator. So 2 is 4 halves. 4 halves minus 1/2 is 3 halves. So log base 4 of x plus 3 halves. I'll put a parenthesis here to make it clear that the log is ending here. All right. Let's see. I guess I will do A here. It says find f inverse of 2, f inverse of -1, and f inverse of x squared. So first we have to find f inverse. Oh, you know, on that last one, I don't love the way I ended up writing this solution. Because it started with g of x, I'm going to end with g inverse of x equals log base 4 of x plus 3 halves. All right. We want to find f inverse of 2, so we're going to switch x and y. This is a y. And we're going to solve for y. We're going to subtract 1, and I'm just going to go ahead and add this all in the same step. We're going to do 2 steps at once here. We're going to do 4 to both sides after we subtract 1. So it's going to be 4 to the x minus 1 equals y plus 5. And so y, which is going to be f inverse of x, equals 4 to the x minus 1 minus 5. And we subtract 5 on both sides. So here's our inverse function. It asks us to find f inverse of 2. So we're just going to plug in 2 here. 2 minus 1 is 1. 4 to the 1 power is 4. 4 minus 5 is -1. I guess I'll go ahead and plug it in before evaluating. This is -1. That is what f inverse of 1 is. F inverse of -1 is 4 to the -1 minus 1 power minus 5. 4 to the -2 power is 1/16. So we've got 1/16 minus 5. To combine those, I need to make them all over the same denominator. So this is 80/16. And so we get -79/16 as f inverse of -1. And the last thing is f inverse of x squared, which is 4 to the x squared minus 1 minus 5. This is a function. That's what f inverse of x squared is. All right. Let's think. Are the following pairs inverses? You just need to find the inverse and see did they match. On the back, I will graph one of these. I'll graph both the function and its inverse. So f of x is 2 to the x plus 5. 2 to the x normally goes through 0, 1. Looks something like this. And what's happening is it's getting shifted to the left by 5. So I'm going to take this point 0, 1, shift it to the left by 5. When x is 1 normally, 2 to the 1 is 2. That gets shifted left by 5. When x is 2 normally, 2 squared is 4. That gets shifted left by 5. When x is 3, 2 to the third power is 8. That gets shifted left by 5. So we get this whole exponential that's shifted to the left by 5. And I'm just going to follow the asymptote here. It's going to be good enough. I guess it should have gone through 1/2, but I'm okay with it. Okay. 2 ways to do this. It didn't say you had to find the inverse function. It just said to graph it. So you could find the inverse. You could find f inverse of x equals blah, blah, blah. Or you could just take these points and switch the x and the y. So I'm going to do that. Negative 5, 1 becomes 1, negative 5. Negative 4, 2 becomes 2, negative 4. Negative 3, 4 becomes 4, negative 3. And negative 2, 8 becomes 8, negative 2. There also was an asymptote at y equals 0, so that becomes an asymptote at x equals 0. So we end up with this function right here, which is clearly a log function. It's reflected across the line y equals x. So this is, it looks like y equals log base 2 of x minus 5, which you could have graphed also by just finding the inverse and then graphing that log function. The domain of f of x is, well, keeps going to the left, keeps going to the right. Domain, all real numbers. Domain of f inverse of x, here, the x values never get below 0, so x is greater than 0. The range of f of x, all y values are above 0, y is greater than 0, and the range of f inverse of x, all the y values keep going down, keep going up. The range is all real numbers. We'll note that the domain and range are switched between the two. That's all.